Hello friends, today we are going to discuss on light and sound. Light and sound both are the waves. Light is electromagnetic wave while the sound is the mechanical wave. In this unit we are going to discuss the following points. Point 1 to be covered, properties of light. First of all we will cover the properties of light. Second, reflection of light, colors, refraction, properties of sound, and finally we will cover hearing, and basically we will limit ourselves to the human hearing. Now let's come to the topic. Part 1, and there is the property of light. As we all know, we all are familiar that light travels in a straight line always. There is a laser unit and there is a beam shown here traveling in a straight line. Definitely, if we talk about the speed of light is too high. It is 3 lakh kilometers per second and it is very fast. It is fastest than anything in this world. At this speed it can go around the world 8 times in a second. If we spread the light through the globe, it can pass 8 times in 1 second whole the globe. Light travels much faster than sound. For example, thunder and lightning starts at same time, but we will see the lightning first. Whenever thunder happens in the sky, we see the lightning first. Then we hear the sound of thunder. When a starting pistol is fired, the smoke first and then hear the bang. We see the smoke first and then we hear the bang. All this is because of speed of light is much faster than speed of sound. We see things because the light reflects, because they reflect light into our eyes. There are different objects surrounding us and these different objects reflect light, and this light enters into our retina where there are some optical muscles, and these muscles senses the light and generate the light signals, electrical signals, and these electrical signals are finally interpreted by our brain. So whatever we are seeing, the light is being reflected by these objects. If any objects not reflecting the light, if any object doesn't reflect the light, we can't see it. So here is sun, as we are seeing sun is here, and this is an object. It's a homework or it's a book. Light rays comes from sun, just strikes the surface and bounces back, making an angle of reflection and just enter into our eyes, where it passes through the eye lens, the vitreous humors, and several parts of eyes, and finally reaches to the retina. The retina is a specialized tissue designed to generate electrical signal when it gets stimulated by light signals. Luminous and non-luminous objects. So as we have talked earlier, that when light strikes on any surface, it gets reflected by the surface. If any surface is illuminated, this surface is known as non-luminous surface. So non-luminous surface also known as illuminated surface. So we see two types of objects. If we are seeing any objects, there may be two cases. The object may be luminous one, means generating its own light. The object which generates its own light is luminous, such as sun, a lightning bulb. A non-luminous objects means illuminated one. Non-luminous objects, rest other objects who don't emit their own light are non-luminous. Non-luminous objects are visible because of being illuminated by the luminous objects. Actually, the luminous objects give them light, they reflect it, they bounce it back, and just they become visible. Now come shadows. How shadows are formed? Definitely shadows are formed where the light is blocked. As in the picture we are seeing, there is a tree and the sunlight, the rays of sunlight are coming here. The light rays are striking to the tree and so the tree is blocking it further. There will be a shadow of the tree. Properties of light. It's a summary. Light travels in a straight line. Light travels much faster than sound, and we see things because they reflect light into our eyes. Shadows are formed when light is blocked by an object. Now there is part 2, reflection of light. Now we are going to understand the phenomena of reflection of light, and in this picture the mirror is shown. The kind of mirror is a plane mirror, and if we strike a light ray on this is a normal. This line is known as normal. This is not a practical line, it's an imaginary line which is just at perpendicular, just at 90 degree, and it is perpendicular to the surface of the mirror. This line is known as normal. If any light ray strikes the mirror by making at any angle with the normal, this ray is known as incident ray, and the ray after striking the surface will get reflected at the same point with the normal, will make the same angle, and this ray is known as reflected ray, shown in blue. And this angle with the normal and the incident ray is known as angle of incidence, and while the angle made between normal and the reflected ray is known as angle of refraction. Now come to the laws of reflection. As in this picture we are seeing here, there's an incident ray in red, and it's strike on the plane mirror and just get reflected by this plane mirror and makes an angle of reflection. So what is the law of reflection? Angle of incident is angle of reflection. This is the first law of reflection. Whenever the reflection happens, this rule is always followed. Reflection may happen in light rays, in any other kind of waves, in sound wave, and sometimes in carom board. When it strikes at an angle, it makes the same angle after being bouncing back from there. Mechanically, the angles may be slightly less or more deviated, but in case of light, the angles are perfectly matched. The second law, in other words, the light gets reflected from the surface at the same angles on it. These are the same angles, angle I and angle R. Both are the same. Clear versus diffused reflection. Smooth shiny surfaces have a clear reflection. If you have a shiny and a smooth surface, it will have a clear reflection. As a mirror, the reflection by the mirror is so clear that we can see our pictures, we can see ourselves in the mirror, and we can see everything with the finest details. But not every object is same as mirror. We can't see our images or the clear details in each object. So it's a plane mirror, and there are some rays striking parallel to the surface of the mirror. They will get reflected parallelly with each other. So the incident rays are parallel to each other, and the reflected one are also parallel to each other. Rough dull surface have a diffuse refraction, and diffuse refraction is when the light is scattered in the different direction. So if we have the surface, rough surface, like in the second figure, this was a smooth mirror, smooth surface, but if we have most probably, practically we have the kind of surface like second one, and if we have this kind of surface, what will happen here? This ray strikes here while it goes theirward, and the ray too strikes theirward while it will travel theirward. So even the incident rays are parallel, the reflected rays are non-parallel. This is known as the diffused reflection, because the reflected ray are diffusing in any directions. Using mirrors, two examples are there. So there are so many uses of mirror. So we can use the mirror to make the kind of scopes, as the object is placed there, and while the person is placed there, the eye are in different direction, object is placed in different directions, but because of the mirror, we have a plane mirror here. The light ray just strikes this mirror and just strike the another one and just come to the eyes, and finally the object is seen. Another application is kaleidoscope, as we are well familiar of it. A periscope. This is known as a periscope. A periscope is a device we can see objects situated in opposite direction, in any direction from our eyes. We needn't focus our eyes towards the object. A car headlight. In a car headlight, we use a concave mirror. A bulb lights up and the concave mirror directs all the lights in forward direction. There is a concave mirror and there is a bulb of a car. The bulb is giving light and this light is being struck to the curved surface of the concave mirror, and the concave mirror is focusing to the light in forward direction. As the rays are being shown here, and all these rays will become parallel because the bulb is always placed at the focus of this concave lens, and whenever the rays coming from focus and is striking the concave mirror, they will become parallel and eliminate the way, the roads. Colors. Now just talking about the color. White light is not a single color. It is made up of a maximum of the 7 colors, as we know the pattern rainbow. This is a white light ray, and when it passes through a prism, it gets separated in its constituent colors, and we come to know that there are 7 constituent colors of light. Now we can demonstrate this by splitting light into the prism. Prism is very common device to use to know how many colors are there in light. This is how rainbows is formed. The color of rainbow: red, orange, yellow, green, blue, indigo, violet. These are the color patterns. If we pass a white light through a prism, this pattern is visible because of the colors of light get separated. White light can be split up to make separate colors. These colors can be added together again. We can add these colors together. The primary colors of light are red, blue, and green. These are the primary colors. In our surrounding sphere, we see a lot of colors: a purple, a blue, a gray, a lot of colors. But in nature, there are only 3 colors, and these 3 colors in different proportions results in different colors, as very smartly shown here. This is blue one, this is green one, this is red one. But when they intersect with each other, when they get diffused with each other, as blue and red get diffused with each other, it makes some purple. If all these 3 colors get mixed with each other, it forms white color. That means white means all the colors. White light means all the color present. When blue meets with green, it gives some light bluish color, and when green meet to red, forms yellow. So yellow isn't a separate color. Yellow is a combination of red and green. Purple isn't a separate color. It's a combination of blue and red, and so on. This is the method, the phenomena of formation of color. Adding blue and red makes magenta, purple, and these are the colors. Adding red and green makes yellow, as I already explained this. The color of an object appears depends on the colors of light it reflects. Definitely, the color of objects in our surrounding, we see a lot of colorful objects. Some are red, some are green, yellow, pink, but basically none of the objects has the color. Colors are only in the light. Any object appears in a color it reflects. For example, a red book only reflects the red light. There is a red book, and there is a white light just touching it. The white light is striking it. White light means all 7 colors are striking here, but all the rest it will reflect only the red color, and the rest of the 6 color will get absorbed by the book. So the book appears to be red. Only red light is reflected. It is the inherent property of the paint on color which is placed on the book. A pair of purple trousers would reflect purple light, and red and blue, and purple is made up by the red and blue. So there is a white light incidence, while the purple will reflect the purple one, the red one, and the blue one. So it will make a purple combination. A white hat would reflect all 7 colors, and it will appear as white. Using colored light, if we look at the colored objects in colored light, we see something different. From example, consider for the football kit. It's a football kit, and there's a different combination of red and blue. And if we look at it in white light, red will reflect the red one, absorb the rest of the colors, and shorts looks red, while the lower looks blue. Definitely, in different colors of light, the kit would be different. If we have only monochromatic light, and monochromatic light means only one color, and we have chosen one red color, and if only the red light is being incident in this, the shirt will be visible, but the lower will not be visible. It will become black. So it will look red, it will look black, because black means absence of light. So there will be no light reflection from this blue part, and this will become black. Secondly, if in a monochromatic light patterns we use the blue light, in this case the blue light will only reflect because the availability is of only the blue light, and the lower the short will look blue, while the shirt looks black. This is the color pattern. This is the final color patterns. If there is a red light emission, so only red light is there, and reflecting the red light is the property of this top. So the top will be visible in red color, while the lower or the short will look black because there will be no reflection. The top has an inherent property to reflect the red light, and if you have only blue light here, the lower only will reflect the blue light, while the short will look black. These are the phenomena. Some further examples are there. Red light, if color of the object seems to be red. If you are looking in the blue lights, it will see the black, and green light black, red light the black. So this is the table. Filters can be used to block out the different colors of light. We can use the filters to block the different color. If it is a red filter, it will filter the red light. So this is a red filter. If it's a magenta filter, it will filter the magenta light. So we can use these filters. Investigating the filters, this is the red, blue, green, white, yellow, cyan, and magenta. Now come to the next phenomena, refraction. Refraction of light. If it diff a scale in a water, it will seems to be bent. This is a phenomenon of refraction. If you pass a white light through a prism, it separates into several colors. And this is a normal phenomenon of refraction. If light rays travels through a glass slab, it just bends towards the normal because it is traveling from rarer medium to denser medium. And when it emerges out, it gets away from the normal because it is entering from denser medium to the rarer medium. There are two surfaces. There is air and there is glass. The light entering from air to glass. Air is rarer medium while the glass is the denser one, so the light will bend towards the normal. It's the natural behavior of light that whenever it enters from a rarer to denser medium, it just bends towards the normal. Normal is an imaginary line again. I'm going to explain it again. Normal is an imaginary line at 90 degree with the surface. When it emerges out, the condition reverses and the light is now coming from denser medium to the rarer one, and it gets away from the normal. If light strikes at 90 degree, then it will pass straight away from the glass slab. There will be no reflection, no refraction, or no remarkable refraction, we should say. Sound is a mechanical wave. This sound wave has a frequency. The sound wave has a frequency. So the sound wave in the first figure will have larger frequency or greater frequency, while sound wave in the second will have the lesser frequency, because it will complete the less cycles in 1 second or less cycles per second. It will complete more cycles per second, while the lambda or the wavelength is very short. The wavelength of this second wave is high. The sound wave has amplitude, loud. The sound wave which has high amplitude is loud. This wave has high amplitude. Amplitude is measured from this position to the height. If there is a total height h, this is the amplitude or the depth, height of the peak or depth of the trough. The sound wave has amplitude is quite. If sound wave has the lesser amplitude, and as we see in the picture, it's very clear. It's clear on looking on these graphs. It has a high amplitude. It has a low amplitude. So it is a quiet sound. It is a loud sound. Hearing. We hear the sound. Sound is a vibration, and we hear when the tympanic membrane or the eardrum vibrates, and it generates the electrical signal. So our eardrum converts the mechanical signal or sound into electrical signal, and these electrical signals finally received by our brain and interpreted as a message. On hearing range can be damaged by several things. We can change our hearing range can be damaged by several things. The much airwax. If we have airwax is a wax in our air. It's naturally occurring chemical or naturally occurring substance in our air to protect our air from dust particle or so any kind of stuffs. But if it becomes too much, if our air releases too much wax, it can block our auditory canal, and the mechanical vibrations may be blocked to reach to the tympanic membrane. The second way, damage to the auditory nerve. If there is any damage due to any accident or any other cause may be there to damage to the auditory nerve. If our auditory nerve is damaged, definitely there will be hearing impairment. Third, the illness or infections. If we develop any illness or infections in our air due to any reason, and if because of this infections our tympanic membrane or eardrum get damaged. The fourth one is old age, and as we know, as we grow old, our body organs respond less, and in old age our eardrum or tympanic membranes or all the auditory nerve or auditory canals or all the parts of air may lack their function, so there will be a hearing impairment because of the age. Other sound effects, the light and sound can be refracted. Sound reflections are called reverberations or echoes. When sound gets reflects, it's known as echo. Refracted. This is why might sound strange if you try talking underwater. Okay, your diagram with the following eardrum. So finally we come to the sound wave sound section to the hearing, and we will understand how we hear. This is a human ear, as we are seeing in picture. This is the outer part of human ear, and this outer visible part is known as pinna. This pinna directs or redirects the signal striking it to the focus. The pinna is made up of several curves, and all these curves has a focus to the auditory canal. So we can say the auditory canal is located at the focus of these different kind of curves present in the pinna. The design of pinna is purposed to collect the sound in all directions and focus it into the central direction towards this B or towards the auditory canal. This tube inside is known as auditory canal. So pinna collects the audio signal and just focuses it to the auditory canals. These signals further transferred to the tympanic membrane or eardrum. This white substance, this white membrane is known as tympanic membrane or eardrum. Eardrum start vibrating, then it strikes to this bone. There are three bones which amplify this sound several times. So these are the hammer, anvil, stirrup bones, and these amplify this sound. The vibration approximately get 10 times amplified by this arrangement and just reach to cochlea. This is a coil-like structure and this is cochlea. And this cochlea is finally responsible to generate electrical signals responding these vibrations. Ultimately, the sound, which was mechanical vibrations, strikes to eardrum, travels through these bones and reaches the cochlea and finally get transferred into electrical signals. These electrical signals are sent to our brain by the auditory nerve, and then the brain interprets the messages encoded with the sound, and that is the human hearing. I hope you can well understand this presentation, and that will be the finest step. If you like that video, click on like and don't forget to subscribe our channel. Thank you. Thanks.